Winter is slowly losing its grip on the plains, and wildlife are starting to plan for spring. Driving gravel roads, you can hear evidence that male greater prairie chickens are starting to gather at group lek sites. On the lek sites, or group mating grounds, the males raise their penny feathers above their head, exposing the bright air sacs on their necks. Their main vocalization is known as booming. When a group of males vocalize at the same time, their voices form a chorus. And that sound travels beyond the lek site to the surrounding space, sometimes as far as 2 kilometers. In a paper published in Ethology in August 2019, our research team evaluated whether the noise from a wind energy facility reduces distance at which the male chorus can be heard away from a lek site. The answer is yes. As with any source of noise that raises the ambient sound in a communication setting, wind turbine noise has the potential to mask sound from prairie chicken leks. The sound remaining above the surrounding noise is called the signal-to-noise ratio, and that sound level declines as the distance from the lek increases. The sound level of the chorus is reduced further at any distance away from the lek when a wind turbine is nearby. Although not as drastic, it's similar to when you try to hold a conversation in a quiet forest compared to on a busy street in a construction zone. But our paper also explores another important angle on the male boom chorus of prairie chickens. Since early biologists first studied prairie chickens, scientists have generally assumed that since we hear sound away from the lek, that sound must have some reason for existing at such long distances. It has long been assumed that male prairie chickens create sounds at leks to show females where the lek site is located and then attract them to the lek for mating. But when we observe behavior on leks, we see a lot of activity between males. The fighting can be vicious at times. Perhaps the sound that carries beyond the lek is just a byproduct of a group of very aggressive males who want to mate. We realized our data allowed us to test these hypotheses. First, if the level of the chorus remained constant, no matter how many females visited the lek, that would suggest that males continued to advertise for more females. Alternatively, if the level of the chorus rose with more females at the lek, that would indicate sound levels were the result of male-male competition. And sure enough, our data showed that the male chorus level rose significantly as more females visited the leks, supporting the male-male competition hypothesis. We also tested the two hypotheses by assessing trends in the level of male chorus during the breeding season. The long-distance advertising hypothesis might predict that male chorus levels would be strongest early in the season and die down as more females became familiar with the lek site. However, our data only showed a small decline during the season. Male chorus levels were high even before females were present in the landscape around the leks, and they remained high for a large part of the breeding season. The small decline provided weak support for the long-distance advertising hypothesis. So in the end, data from greater prairie chickens in Nebraska suggests the sounds we hear in the spring as we pass a prairie chicken lek are not for us or for female prairie chickens to hear. More evidence suggests that these sounds are just the wonderful sounds of male prairie chickens doing what they do best, fighting for the best spot on the lek to gain more matings when the females arrive. Prairie chickens will always have more to share with us, but for now, our work will help conservation planners evaluate the risk of building wind energy facilities near prairie chicken lek sites. Thanks for taking time to learn about our work. We invite you to Nebraska to see the prairie chickens next spring.